Okay, so we're having to go at points of intersection. So this is a bit like simultaneous equations. However, with parametrics, it's going to look a little bit different. We're going to be substituting, yes. However, we're going to be substituting typically more than once. So let's take a look at this. The diagram shows a curve C. The equations are x equals this and y equals this. So x is a function of t. In other words, as t changes, that changes what the x value is. And at the same time, as t changes, it changes what the y value is. And then you can plot those together and you get this shape. A is, so hang on, t is any real number. So in other words, t can be anything. So that's going to affect what kind of values we can get from this. A is non-zero and it's underlined, so that's probably going to be useful in a minute. And we are told that C passes through this point, and we can see that point there. So that's an X and a Y value. So a good first step might be to substitute these in the equations and see what we get. So if we put it in the X equation, we would get -4 equals, I'm going to factorize the t here. Yeah, I think I will. T AT plus 1, just in case I spot anything. But it doesn't really look that useful. Okay, so let's try the other equation. So 0 equals a t cubed plus 8. So we might be a little bit stuck here now. A good strategy then would be to go back to the question and think about if there's any information we haven't used. So a is not allowed to be 0. Well, that means that I can do a bit more with this. Something times something equals 0, and the bit on the left is not allowed to be 0. Therefore, 0 must be equal to t cubed plus 8. And if I solve that, I can get that t equals -2. So you get this coordinate here when t is equal to -2. So I've used what I know about the y part to help me get a t part. So why don't we use that now well, what else could we do? We could use this to help us get an x part. And this is quite a common thing for these kind of questions, okay? You know something about y, you find t, you get something about x, or maybe it might sort of end up going the other way around, okay? But it's quite common for the questions to do something like this. So let's use this value now with the one at the top. So I can still use -4 because -4, 0 is a coordinate. So they have the same t value to result in this. So -4 equals, now t is -2. And I don't know what a is. A times -2 plus 1. Let's write that over here. So can we clean that up a little bit? Yes. So -4 equals, I think I'm going to just divide that by -2, would equal -2a plus 1. Clearly that's 2. Take away 1 from both sides. 1 equals -2a. Divide by -2 both sides. A equals -1/2. So what kind of letter is A? A is constant. So now you found A, that's it. A is A. So you can plug that back into these equations and you can probably do some more stuff with them. So let's do that. So let's say A equals -1/2 t squared plus t. And I'm probably going to use that again now. And y equals -1/2 t cubed plus 8. So find the coordinates of A and B where it crosses the y-axis. So what do I know at this point? I know that x is 0. So I'm going to use the fact that x is 0 to help find out when that happens, which t value results in that. And then I'm going to use that to find out my y value. Okay, so I'm just going to be bouncing between them. I don't think you need me to do that question there, okay? But I'll just give you the start of that. So we know it's about the x part, so I would say 0 equals minus a half t squared plus t. And what's interesting about that, if you factorize t out, is you can see that there seems to be 2 times. There's when t equals 0, and there's this other time here as well, which is when what? Which is when t equals 2, that will be. So you're getting 2 answers. Well, why are you getting 2 answers? You're getting 2 answers because it crosses the y-axis twice. So now you would use these t values in the y equation and you get your final answers, okay? And it seems like they should both be negative. And, well, t is 0 is a really easy one to just quickly put in. So that's going to be minus 4, for example. 2, well, 16, we might as well just work it out at this point. So that's going to be minus 8. Okay, so that's that kind of dynamic of bouncing between the y and the t and the x and the t and the y. Substitution really is what we're doing. This one here is a little bit different. So this kind of catches people out. So x equals t squared, y equals 4t. This is like all of this together just describes one curve. Okay. And there's this line here. And this situation meets this situation here. So when does it meet? Well, you want to substitute, but you're going to do it a little bit differently. So instead, what you're going to do, because of the way that it's written, is you're going to substitute in the x bit and you're going to substitute in the y bit. Okay? So x plus y becomes bracket plus 4 equals 0. The x bit is going to be t squared. So we're solving them simultaneously, right? It's like when the lines cross, remember, you sort of solve simultaneously. So we're going to have t squared and 4t plus 4. And what could you do with that? Well, could we factorize this? I think it's just this one, isn't it? Should we just check that? T squared plus 4t plus 4. Yep. So t equals minus 2. And then I'm going to substitute this information back in. I could put it into either, but, well, I can't actually. I can only put it into this one at the top. So x is t squared. So x is 4 and y is 16. It meets the curve. Find the coordinates of this point. So look, you only get one t value here, and so you get one coordinate, which was 460. Okay, so a little bit different this one because you're substituting in the parametric bits of the line to a Cartesian line for the other one. So you do need to watch out for that one a little bit. Let's have a look at the next one. So this is kind of the test your understanding question. I think this one is, no, it's not. Sorry, we're not just there just yet. Let's try this one first. So x equals all of this, y equals this. So x is a function of t, y is a function of t. T is a little bit more restricted. So when t is restricted, if it's restricted too much, it will affect the x values that you get out. It will affect the y values that you get out. So we need to keep an eye on this because this might do something interesting. Let's do this part first. Find the point where the curve, so where is this? This is all one thing, remember? When is this equal to this line? The line is y equals pi squared. Well, let's simultaneously solve with the y's, okay? So pi squared equals t minus pi over 6 squared. We can cancel those squareds. And we could move, couldn't we? We could move that pi over 6 to the other side, and we would get that t equals 7 pi over 6. Now, let's just keep an eye on this. So does that work? Is t allowed to actually be that? So the denominator is 3 here. So if I multiply 2 top and bottom, I would get 8 pi over 6. So this definitely fits. Okay, this is definitely a t value. It also says find the point, which suggests that one t-value is correct. So what am I going to do now? Well, I'm going to substitute that into the x equation. And I'm going to substitute it in radians as well, because that's what t is. So x equals cos of 7 pi over 6 plus sine of 7 pi over 6. Okay, and you'd get your answer for that one there. Okay, the y part is just pi squared. Okay, because that was given to you in the question. So that would be your coordinate. Find the coordinates. Right, so hang on, we're not going to be able to do that one right now because we don't have that sketch on the board. So we'll skip that one for now. Let's have a look at the final question that we do have a picture of. So we've got a curve C. We've got some points of interest here, A and B. These seem to be intercepts. I've got -1. Okay. It shows a sketch with these equations. So that pair of equations describe this curve here. Okay. So the curve crosses the y-axis at A. Yeah, I can see that. And the x-axis at B. So I'm allowed to use that information. That's why they've told me that. Show that. So show that A is 0, 3. So what can I see visually at A? Well, it crosses the x-axis. So that means that at A, the y bit is equal to 0. So let's put that into the y equation. So 0 is equal to 2t minus 1. Move the 1 to the other side. 2t is equal to 1. What does a power have to be such that you get 1 as the answer? Clearly, t is equal to 0. No need to do logs. You can just do that by inspection. So t equals 0. So now I need to use that in the x equation. So x equals... sorry, I've actually done... have I done that the other way around? I have, yes. Look, that's B. Tell you what, we'll carry on with B because that's the part B question anyway. So at B, y was 0, t is 0 then at that point. So for this one, you have to find the x. Right, okay, so you write the x equation. So x is 1 minus a half times 0. So clearly, x is just 1. Find the x part. That's done. Right, let's go back and do the bit we should have done first. So A, what can I see at A? I can see that the x bit is 0. So that would mean that 0 equals 1 minus half t, which would mean that t needs to be 2. And then if I put that in the y equation, the y part is equal to 2 to the power of 2 minus 1. So y is equal to 3. Okay, so really they are the same sort of question, just different ways around. So use the information from the picture. And again, we've got that dynamic of bouncing between x to t to y, or y to t to x is the way it tends to go. Right, and that's for that part there. Okay, so points of intersection. What did we see? We saw that a lot of it is about substitution. However, there are like little sort of things that are going on in the question that you need to be careful of. For example, the top one here, I think it's actually quite hard to answer this question if you don't read carefully. The second one, more substitution, but in a way that perhaps is a little bit more unusual, a bit more unfamiliar. We did an example here with some trig, so we didn't do the B part because we didn't have the picture, but hopefully you kind of got an idea again from the part A. And then we had another example here from using a diagram, and we were doing some powers in this one. So it could come with a situation like this.